In this video, let us learn to calculate velocity of ultrasonic waves in a given liquid medium and compressibility of the liquid using ultrasonic interferometer. The liquid medium which is taken for calculation here is water, which is most readily available in all the laboratories. Here, the readings are taken in a micrometer scale which is attached to the ultrasonic interferometer, and the least count of that uh, micrometer is 0.01 millimeters or 0.01 into 10 power minus 3 meters. This set of reading is taken for keeping the gain at 50. In some laboratories or some teachers would advise you to keep the gain, they will ask you to take the readings for two sets for by keeping the gain at minimum and another to repeat the experiment by keeping the gain at maximum. But this set of reading is taken by keeping the gain at 50. The order followed here is at an interval of 4 oscillations or 4 deflections. So, the order is n plus 4, n plus 8 till n plus 28. Even you can go till n plus 40. It is up to you to stop where. Here we have stopped till n plus 28. So, there will be two readings in the micrometer. One is the pitch scale reading, other one is the head scale coincidence. In some teachers may advise you to fix the n at the pitch scale of 25 and the head scale of 0, or some may start randomly. So here it is, we have screwed the micrometer to till the last reading. So the first reading n is noted down here as the pitch scale as 24 and head scale is 47. And to get the total reading, we have to multiply the head scale coincidence into the least count. So 47 into 0.001 will give us 0.47. With this, we have to add the pitch scale reading. So we got 24.47. For the next reading, n plus 4, the pitch scale is 22 and the head scale is 40. So the total reading is 22.40. In the same way, we can find the total reading till n plus 28. For n plus 28, the pitch scale reading is 13 and head scale coincidence is 40. So the total reading is 13.40. Next, here the difference is taken for 4 lambda. See, for one wavelength, two consecutive deflections will give you the length of a one wave. Here, we are going to calculate 4 lambda. That means if I find the difference between n and n plus 8, I will get it for 4 lambda. Even you can calculate it for 2 lambda, you can go for 6 lambda, 12 lambda, 10 lambda, anything. It is your choice to choose the lambdas. So here we have calculated the differences for 4 lambda. So n and the readings corresponding to n and n plus 8 gives the difference of 3.12. That means 24.47 minus 21.35 gives us 3.12. The second combination is n plus 4 minus n plus 12. Again, it also corresponds to 4 lambda. So 8 oscillations, that will give you 4 lambda. So 22.40 minus 19.26 will give us 13.14. So the next combination is 21.35 minus 18.12 will give us 3.23. In the same way, we can calculate till n plus 28. So if you do the difference of n plus, the reading corresponding to n plus 20 and n plus 28, that is 16.30 minus 13.40, we will get 2.90. If you look at the last column, that is the 4 lambdas, we got 6 values for 4 lambda. So almost all point around 3. So 3.12, 3.14, 3.23, all points around 3. So we can take the average of all these 6 numbers. If in case one or two values deviate from the constant value, you can very well leave out that value and take the average of the remaining values. So add the 6 values, you will get 18.53, and you divide it by 6. Since we have 6 values, you divide it by 6. So the mean 4 lambda obtained is 3.088 into 10 power minus 3 meters. Next, we need to calculate what is the length of the one wave. So we are finding out what is lambda. So lambda is equal to 3.088 by 4, since it is a 4 lambda. If you calculate it for 8 lambda or 5 lambda, then you have to divide it by 12 or 5, whatever you have taken. So when you divide it by 4, you get 0.77208 into 10 power minus 3 meter. Okay, now let us calculate the velocity of ultrasonic wave in water medium. The formula to find out the velocity is F into lambda meter per second. The velocity of an ultrasonic wave in water medium or in any liquid medium is given by velocity V is equal to F lambda meter per second. The F is nothing but it is the frequency of the ultrasonic interferometer. It will be mentioned in the interferometer itself. So F is equal to 2 into 10 power 6 hertz. Then the lambda value just now we have calculated, which is 0.77208 into 10 power minus 3 meters. Let us substitute in it. So 2 into 10 power 6 into 0.77208 into 10 power minus 3. Then let us keep all the numbers in one side and powers at the end. So it is 2 into 0.77208 into 10 power 6 and 10 power minus 3. When you multiply the numbers, we get 1.544. When you add up the powers 10 power 6 plus 10 power minus 3, we get 10 power 3. So the velocity of the ultrasonic wave in water is 1.544 into 10 power 3 meter per second. The reference value for the velocity of ultrasonic wave in a water medium is 1.5 into 10 power 3 meter per second. We have gotten value which is in close agreement with the reference value. Next, let us find out the compressibility of water. The formula to calculate the compressibility is C is equal to 1 by V square rho meter square Newton. We know the density of the water to be 1000 kilogram per meter cube, and the velocity just now we have found it is around 1.544 into 10 power 3. So let us put it in the formula. It will come out around 1 divided by 1.544 into 10 power 3 the whole square into 1000. This 1000 can be written as 10 power 3. The power inside that bracket value 10 power 3 the whole square. When you square it, you get 10 power 6. So this 10 power 6 and 10 power 3 will add up to 10 power 9. And squaring 1.554 will give us 2.384. So then when you take the reciprocal of that 1 divided by 2.384, we get 0.41946. And the 10 power 9 in the denominator, when it goes to the numerator, it becomes 10 power minus 9. I am going to move a decimal on the left hand side. When I move it, I will get 4.1946. So your power will diminish by 1. So it is 10 power minus 10 meter square Newton. So finally we can summarize our results. The velocity of ultrasonic wave in the liquid medium, what we have calculated is V is equal to 1.544 into 10 power 3 meter per second, which is against the reference value of 1.5 10 power 3 meter per second. I mean, we can say it is in a close agreement. It is not against, it is almost in the close agreement with the reference value. The compressibility of the water is C, what we have obtained, C is equal to 4.1946 into 10 power minus 10 meter square Newton. but the reference value is around 4.6 into 10 power minus 10 meter square Newton. This also doesn't deviate much from the reference value. We can repeat the same experiment with the kerosene, toluene and benzene in the same way.